But before we get into the presentation on additive manufacturing, I firstly wanted to go over some housekeeping to give you a brief overview of NMIS, what it is, what the objectives are, and how NMIS will be structured. So housekeeping, the webinar is being recorded and will be made available on our YouTube channel. Your microphones and webcams will be turned off during the session to avoid background noise. You can type your questions throughout the session via the chat tool. Time will be allocated at the end for the speakers to answer your questions. Use the hashtag NMISinsights for any questions on Twitter at NMIS_group. And please take some time to complete our survey that you will be sent after the webinar. So what is the National Manufacturing Institute Scotland? The National Manufacturing Institute Scotland is a group of industry-led manufacturing research and development facilities where research, industry and the public sector work together to transform skills, productivity and innovation to attract investment and make Scotland a global leader in advanced manufacturing. NMIS will increase productivity by reducing barriers to innovation, stimulate investment and increase manufacturing competitiveness, catalyse job creation and strengthen supply chain links, inspire and attract talent and equip current and future workforces with the skills they and their businesses need, and work with manufacturing businesses of all sizes and multiple sectors, providing benefits across the whole of Scotland. So NMIS is a One Scotland team. NMIS is operated by the University of Strathclyde. However, it is much broader than that and supported by the Scottish Government, Scottish Enterprise, Highlands and Islands Enterprise, the High Value Manufacturing Catapult, Skills Development Scotland, Renfrewshire Council and the Scottish Funding Council. So the NMIS group is a combination of core NMIS capability, specialist technology centres and an active network of partners in the manufacturing community. As you can see in yellow here, we already have specialist centres that are up and running, and the AFRC being the most established here, and it's been delivering forging and forming research for around 10 years. One of the newer centres, we also have the Lightweight Manufacturing Centre, which is located in the Westway facility in Renfrew, and that officially opened in 2019 by the First Minister, and that's looking at lightweight materials, including composites. And Ian Bomfrey and his team presented an earlier NMIS Insights, which is also available on our YouTube channel. So we're also developing an outreach with the NMIS network, and that's such as councils, bodies and institutions around Scotland. And we have temporary space for projects and new capability areas. So the LMC being an example, but we'll also see additive manufacturing and machining processes being housed within these temporary facilities as we grow. The Digital Factory, the Manufacturing Skills Academy and the Collaboration Hub are being built at Glasgow Airport and will be available around 2022. But just to let you know that we're not waiting on these facilities to be built, and the Manufacturing Skills Academy, for instance, is already developing continual professional development courses, as well as the Digital Factory is also delivering out of our digital team at the AFRC. So just focusing on the Digital Factory for a second, it will focus on areas such as automation and assembly, digital engineering, lightweighting, machining, and the topic of today, additive manufacturing. So hopefully that's a little bit clearer on NMIS and where additive manufacturing sits within that NMIS wider structure. I just also wanted to mention that the AFRC is part of the High Value Manufacturing Catapult and the only one in Scotland. And in areas such as additive manufacturing, it's important that we want to really use the strength of that Catapult network when developing AM processes, and particularly with centres such as the MTC, who host the National Centre for Additive Manufacturing. This is a slide that a number of you have probably seen over the years, but I just want to reiterate that we are mid-TRL research and development, and what we want to do is translate the research and development into industry towards TRL 7, 8 and 9 to increase productivity for businesses. So just the agenda. So we'll now focus on AM. So I'll give an introduction to AM and the current and future confirmed capabilities at NMIS, and Mizel will also join the discussion on the wire capabilities. Today's presentations will be relatively high level, so we aren't going to go into too much technical detail in this webinar, but we plan to have future webinars on additive manufacturing where we can go into those technical details. And then Grant will discuss a project that we've just started, which is aimed at supporting the adoption of additive manufacturing for Scottish SMEs. And that's a project called AMBATS, or Additive Manufacturing Business and Technology Support. So just want to give a little bit of background and market information on additive manufacturing. The numbers are a couple of years old, but do give an idea of the additive manufacturing market. They've been taken from the Waller report, which is a trusted market analysis report on additive. So the worldwide market in 2017 was around 6 billion, with expected to grow to around 20 billion by 2022. The UK had around about 5% market share of that, about 300 million GVA, and that was expected to grow to about 1 billion by this year, and 3.5 billion by 2022, so tenfold over that 5-year period. Now, obviously, the markets have changed quite considerably over the last 6 months, but nevertheless, that is significant growth. And that would come from the production of AM components, creating supply chains of additive manufacturing parts within the UK and through equipment and services. So, I mean, in order to realise this, there's a need for innovation, for investment, and to upskill our current and future workforces in this technology area. So we've got a very diverse group on the webinar today, and some who haven't came across additive manufacturing before. So I just want to take a step back and quickly go over a bit of background on AM and the benefits, before moving into the NMIS focus section. So we know our traditional conventional techniques. We've got subtractive techniques such as machining, forming, forging and forming, and casting techniques, and fabrication. Whereas additive manufacturing is the process of joining materials to make parts from 3D model data, layer upon layer. So it does have some distinct and unique advantages, for instance, rapid prototyping, where it's been used for, the last 20 to 25 years. Or novel tooling and fixturing for areas such as injection moulding and for conformal cooling. To give us design freedoms that aren't possible with conventional manufacturing techniques as well. And to increase performance, optimising through thin wall structures for things like heat exchangers and creating complex internal channels. And part consolidation, whereby you'd have to weld components together or bolt them or fasten them together. You can actually then create more part consolidation through the additive manufacturing process. And customization, we've seen this through the dental industry, through dental implants, and the medical industry as well as customization through the consumer industries. In high integrity sectors, it's an area that we've been focusing on predominantly, and sectors such as the oil and gas, the aerospace and automotive sectors have embraced additive manufacturing over the last few years. So there are 7 processes as defined by ASTM and ISO. They are VAT photopolymerization, material jetting, material extrusion, binder jetting, powder bed fusion, sheet lamination, and directed energy deposition. All of their application with specific advantages and disadvantages. Some are polymer based, some are metallic based, some are composite ceramic, some have size constraints and constraints on design. So, additive certainly can unlock additional value over conventional manufacturing techniques, But I would say that you do need to remember that it's not the best process for everything. And at the end of the day, it's another manufacturing process, and it's another tool in the toolbox, if you like. Now, I appreciate there's some new novel AM processes that don't necessarily follow this convention, and we have a few projects running currently on some of those novel techniques. But for the purposes of this, we've followed the ASTM convention. So as I've mentioned, there's 7 processes. And at NMIS, we're committed to developing 4 of those 7 processes around material jetting, material extrusion, powder bed fusion, and directed energy deposition.
Sorry, Stephen, I just had a bit of background noise there, so I've just muted everyone. If you could please turn on your microphone again, Stephen. Thank you.
Okay, thank you, Laura. Thank you, Laura. Yeah, so as I've mentioned, we'll be developing 4 of these 7 techniques: material jetting, material extrusion, powder bed fusion, and directed energy deposition. Some of these technologies are online just now, while some are being commissioned, but they are all committed investments. So I'll begin with directed energy deposition, and the next 2 technologies fall under this category. So directed energy deposition uses powder or wire as a feedstock, and you can use a laser, an arc, or an electron beam as the energy source to melt, fuse, and layers together. It's the process that we focused on for a number of years, and I'm going to talk about one of those processes, laser metal deposition. So as you can see, this is a hybrid platform where powder is blown through a nozzle, and using a laser as an energy source creates a melt pool. It does have specific benefits over arc welding techniques, as it has a relatively low heat input, and you can get better benefits of lower dilution, faster cooling rates, which give you a finer microstructure and lower thermal distortions. It is also quite an accurate process, so you can create more near net shaped components. However, it does have a slower deposition rate than arc-based processes, and powders bring their own challenges with them as well. So it's a process that we've been working on for around 6 years at the AFRC, and currently a number of projects are around tooling repair, and also with sectors such as the oil and gas sector and the aerospace sector. So what we wanted to do with this platform was introduce it at a low cost to show industry how they could adopt this. So with our partners, Hybrid Manufacturing Technologies, we've retrofitted a legacy system with this technology. So it does have a 1.5 kilowatt fibre laser, 1 and 2 millimetre spot heads, and the capacity up to about 2 metres in length. So this technology is used predominantly for deposition, but it is also a hybrid platform where you can quickly tool change a milling head in and carry out machining or scanning or metrology and NDE. So this process is suited for repair and remanufacture, for high integrity coatings and layers, for adding features onto existing components, and also for building 3D structures. And in terms of where this technology sits, I would say that the readiness level of this technology sits from left to right. And if you had an application for full component manufacture, and it's probably really need to have a strong business case behind it, as it's more suited to repair, coatings, and feature addition. So staying with directed energy deposition, I'm just going to hand you over to Michelle, who will discuss the arc-based processes that we have.
Thanks, Stephen. So first of all, if you compare powder with wire, what we expect is that you can work with larger components. You have also higher deposition rates, and then you have better productivity on the manufacturing routes that you're selecting. Also, wire compared to powder is cheaper, and this is because one, which is wire arc additive manufacturing, is based on welding technologies which are quite well established nowadays. We had some good structural integrity components that have been produced using WAM previously, making it a suitable candidate for replacing or working with some traditional manufacturing routes, for instance, of solid billets or large forgings, but especially with low and medium complexity parts. There is a variety of components that have been successfully manufactured before using WAM, and this includes titanium 64 spars and landing gear assemblies, or aluminium wing ribs, or steel wind tunnel models and cones. But with that said, we currently have 2 WAM robotic cells at the Lightweight Manufacturing Center today. The first one is seen in front of you, and this utilizes gas metal arc welding process. It has a 1 6-axis cooker robot within it, and 1 2-axis positioner that allows you for flexibility, so you can rotate the table while you're doing the position of the material. It's an enclosed atmosphere, which means we're quite comfortable working with reactive materials. And then compared to welding processes like plasma arc, it is a low-cost, high-efficiency process. The second one, the next one, is utilizes a plasma arc welding process, and then different from gas metal arc, it is cleaner and more precise when you're working with it. What you see in front of you is the result of a project that we have called RoboWAM, and this aims for developing and commercializing WAM cells. This project is with partners such as KUKA Robotics, Cranfield University, and Technip FMC. So what you see is that we have 2 robots. The one on the left is for the deposition of material. The one on the right is for a non-destructive assessment, and that's actually a key factor for us. We not only want to print components, but also make sure that they have high integrity, so no porosities or discontinuities within them before any post-processing. This is a work that we've been carrying out with the Electronic and Electrical Engineering Department at the main campus of the University of Strathclyde. You cannot really see on the pictures, but it's an open atmosphere differently from the previous one. And this means that we can go for medium to large sized components. But also because of that, we would require some protection of the deposited material. And that's why we have a shielding box on it that was provided by Cranfield University that is part of this project. With that said, I'll now pass you back to Stephen.
Thanks for that, Michelle. So when you look at directed energy deposition processes, it fits well with the AFRC, and they align and complement well with, the existing forging and forming technologies and our current customers or members and the sectors that we work in. So I think there's a huge opportunity for companies to integrate these technologies within their products, and we'll continue to develop and invest in them. But we also need to strengthen Scotland's manufacturing landscape. And, while these DED technologies will play a significant role in that, there are gaps which mean we can't support a broader range of Scottish manufacturing the way that we need to. So hence the reason for, the next couple of technologies, which I'm just going to introduce, metallic laser powder bed fusion and polymer EM capabilities. So laser powder bed fusion, it's conducted within a chamber, selectively melting a powder within the bed, and you can create complex 3D structures which offer key benefits such as the design freedoms, like are shown in the images to the right here. And if you've seen metallic parts such as these, the likelihood is that they've been created through the powder bed fusion technology. So what we've invested in is a Renishaw 500 series machines. They do give a build platform of around 250 square and a single 500 watt laser. Now we do know that there are multi-laser systems on the market which increase productivity, but they are more production orientated, which means it can be difficult to change in and out materials. So what we wanted to do with this system is have a system which allowed us to change different materials to give us more flexibility. So we've sacrificed a little bit of speed and productivity for flexibility in this instance, but we can work with Renishaw to increase productivity through, for instance, the quad laser systems if need be. However, I mean, there is significant infrastructure required to house these machines. So to ensure the health and safety and quality are being adhered to, we've had to delay the building due to COVID-19. So this has delayed the machine installations and commissioning to Q1 of next year. But with the metallic powder bed fusion, that will allow us to support companies, in a number of different sectors and very different applications to which we can currently support the Scottish manufacturing landscape. So, now we'll move on to the polymer capability, which is the material extrusion and material jetting processes. And this is a Stratasys F900 large build volume FDM printer, and that is within the material extrusion family. With this process, material is drawn through a nozzle, where it is heated and then deposited layer by layer. As I mentioned, this is the technology you see in your home or hobbyist 3D printing. However, this is in a production scale with a large build volume of over 900 millimeters. You can deposit a wide range of materials. All of the material types are opened up. Sometimes with Stratasys, all these materials aren't opened up, but we have opened up all the materials. So it does give us opportunity a lot around, thermoplastics, high performance polymers, and even chopped carbon fibre. So in terms of, the types of components, as you can see in the images here, it's large tooling, composites tooling, jigs and fixtures, but also prototyping and even, production parts. So I would mention that we also do have a range of FDM desktop printers. However, for the purposes of this session, we're just looking at the production machines. And then finally onto the PolyJet capability, and that's part of the material jetting family, where you build the surface onto the platform, and that is then cured or hardened using an ultraviolet light. And you're able to print in full colour, different textures and colour gradients, print opaque and clear, and it has a wide range of flexible and rigid materials. So again, you can see from the images, this is very suited to, product designers who create prototypes and concept models. But it can also be used for an engineering concept for things like, robot grippers, for instance, and then even companies like Baker Hughes were excelled in creating the FFP3 masks in this technology during the COVID outbreak. So, it can be used for industrial applications. So again, when we look across the two polymer capabilities, it does give us, different applications across engineering, tooling, prototyping and product design, and opens up new opportunities for companies to work with us. But again, I just want to reiterate, we aren't saying that we have every solution. And what we want to do is use the strength of the Catapult network, particularly, the National Centre for Additive Manufacturing at MTC. And we envisage, particularly in areas such as, powder bed fusion, that we are more of a hub and spoke with the network within the Catapult. So I guess what we've done here is we've focused quite heavily on the process and equipment, but capability lies within the people. It doesn't lie within the equipment. So within the team itself, we've got 16 engineers currently and researchers, and that is growing over the next few months as well. And further to that, we've got a range of complementary capabilities across the process chain, such as design. We've got a strong materials, residual stress and modelling capability, currently work in additive manufacturing, and also advanced machining capabilities as well. Right. We have our, strong residual stress team and non-contact measurement, and as Mizel touched on, working with the Centre for Ultrasonic Engineering at the university, they've been working on non-destructive evaluation techniques on additive for a number of years, with sectors such as the oil and gas and aerospace sector. So using the full NMIS capability, university capability in the HVMC network, we'll be able to support that full process chain through design, through the build process, through the analysis, post-processing, and working with third-party institutions we'll be able to support through the certification and qualification. So just to recap, we are developing 4 of the 7 EM processes in directed energy deposition, powder bed fusion, material fusion and material jetting. And these cover, both powder, wire and polymer feedstocks. So hopefully that hasn't been too confusing and you've found some of that interesting. But I appreciate, there may be some questions around, where do I start? How do I know what process is suitable for me? And what process would I select? And, how would I leverage the maximum benefit for additive? So what I want to do now is hand over to Grant, who'll go over a project which is aimed at doing just that to support SMEs in Scotland.
Thank you very much, Stephen. The project I'm going to talk to you just now is the Additive Manufacturing Business and Technology Support, otherwise known as AMBATS. So the AMBATS project is part funded by the European Regional Development Fund and managed on behalf of the Scottish Enterprise through the Advancing Manufacturing Challenge Fund, which is also known as AMCF. So the lead research institution on this is University of Strathclyde, and more specifically, the National Manufacturing Institute Scotland. Stephen is the principal investigator on this project. I'm the project lead. And the project has been running from April 2020 and is due to conclude on the 31st of December 2022. So looking at the Advancing Manufacturing Challenge Fund, it's really aimed around advancing manufacturing capabilities of SMEs within Scotland. And the goal of that is to lead towards long-term transformational change. And that's achieved through innovation, the reinvention of the workforce, adherence to horizontal themes, development of the supply chain, which will encourage growth, and more specifically, what we're talking about in this project, the adoption of new processes. If you want to find out some further information about the portfolio of projects, further to what I'm going to discuss in this presentation today, there's a web link below there. So, how's this going to work, and what is the project? We are really looking at providing SMEs with the skills and knowledge required for them to make the correct business technology investment decisions in additive manufacturing. And we're going to do this through de-risking innovation. And what we mean by that is we have already invested heavily in all the different technologies. So you can come and work with us without having to make large capital expenditure investments up front. So we will support you through the adoption process of additive manufacturing and really look at it to see if it is the right thing for your business. And through this, we will also be working to really grow that Scottish supply chain. So really what we're doing is giving you the confidence to be able to make the right decisions to invest in additive manufacturing processes, but also the capabilities and technologies around that complement it that Stephen had discussed. So we've looked at this and we've broken it down into some key challenges for both existing engineering companies, but also other companies that are just newly formed. So we've assessed that you really need this in-depth knowledge to make these correct decisions in which technology suits your business. We have the expertise and process understanding that we can transfer to you, which will ensure that you are competitive in the marketplace. And we'll also work with you to help you understand the complex supply chain, which in essence will make you more financially sustainable. And as Stephen alluded to earlier, with some of the processes in particular, such as the powder bed, there's a lot of difficulty and complexity when it comes to facility design. We've gone through this process, and also with the network of other catapult centres, we can really help you with that. And then that will allow you to adhere to all the health and safety guidelines, and also that will trigger business efficiencies. So really what the takeaway from this is that you should be working with a work smarter, not harder approach, and that will really be imperative to your success. So we are working across Scotland, pan-sector, And if you don't feel that you're represented on this this image here, please do just let us know in the comments section and we'll gladly add you to it. But what we're really trying to convey here is that additive manufacturing is really a transformational technology that has the ability to enable innovation across any sector. So it's really worthwhile coming and speaking to us and seeing what we can do for you. So we did some work where we were looking at the existing Scottish additive manufacturing landscape. And again, if you are not represented on here and you'd like to be added to this diagram, please do just let us know and we'll add you to there. You have some vendors in Scotland, such as Angus 3D Solutions in Brecon, and you also have CA Models in Stirling. But what is worthwhile realizing and seeing in this diagram is that it's mainly large companies who are working within additive manufacturing and also universities. So the fact that the supply chain is fairly limited at the moment is potentially damaging for Scotland's future manufacturing landscape. As Stephen described earlier, it is going to form a large chunk of the manufacturing industry as we move forward. So projects such as this and the wider AMCF portfolio of projects are in place because we have realised at a regional and national level and even international level that investment and growth is going to be key to success as we come out of lockdown. So in terms of if you have an idea about how you want to use additive manufacturing, what this diagram shows is we're covering the whole range of potential ideas. So whether that is a brand new component that's completely new to your company or just a completely new product, we can look at how we bring that to the market for you. Also, it could be an existing component that you have, and we can look at how could additive manufacturing be used to make this part better. It may be, as Stephen described earlier, where we're looking at taking components from an assembly and consolidating them into a single component. And this could enable benefits such as lightweighting, increased strength, or even potentially added functionality. Then with the regenerate, we are looking at the repair, remanufacture of components such as tools, molds, and dies. And lastly, depending on the maturity level, if you're at that stage where you're just ready to commercialize, we can work with you to ensure, and also with third parties, to ensure that all your documentation is in place. Again, working with the third parties to help you get in a stage where you can qualify your process, which all leads towards ensuring that your component or product is certified to be accepted in the marketplace. So how are we going to do this? We have developed and we are developing a series of work packages. And what this shows you here is just a flavour of what some of these may be and some of the content that sits within them. And again, depending on what your business is, what your product or component is, and the maturity level of that, you can come in and in this scenario, you can kind of cherry pick the business packages, support packages that are aligned to what you need. And we will sit down and go through this with you and really pick out the best ones for you. However, it may be a case of you really need to do a full end-to-end process. And that could be looking initially at the product suitability for additive manufacturing. From there, we'll then move through to selecting the correct process, developing the business case, and then we'll map out this additive manufacturing journey for you. And then within this, we start to look at some of the more niche things such as resource efficiency and sustainability, working with the third-party organizations to ensure that your process is validated. So that may be working with a vendor who may be your manufacturer, or in the case where you decide that you want to make the capital expenditure and invest in additive manufacturing technology, we can work with you to help you set up, whether it's a factory or even a cell within a factory to do that. And then again, working with you at that final stage with the third-party organizations to ensure that you've got support towards approval, so your product can then achieve certification. And then again, depending on what the maturity level of your product is, we can then push even further and really look at process development, fine-tuning and honing everything that you're doing, which will then enable you to be more competitive in the marketplace. So you may be asking yourself, how does this all actually work? So what is worthwhile describing is the fact that the SMEs in this project are really at the heart of the process. But there is a network of support around you. So you have the National Manufacturing Institute Scotland, you have SEED, who are doing a parallel activity, which is building clusters, which I'll describe to you in a moment. You have the portfolio of AMCF projects, of which there are 12 in total. And then within that, there is the AMBATS project that we're talking about just now. But we should also consider that there is the existing Scottish additive manufacturing sector that we're looking to support and also boost as we move forward. So how are we going to do this? So we are delivering a series of webinars, of which this is the first. Further information will be published about the webinar series just shortly. The support packages will be available to the SMEs, as I previously described. And what this does is it unlocks access to specialist support and also the equipment at NMIS. And what that really allows you to do as a company is develop prototypes, whether that is digital or physical as well. So the cluster building activity, and I've seen that Gillian Wisher from SEED is actually on this call, which is great. So the SEED cluster building activity is a parallel activity to the AMCF projects, where they're engaging with the manufacturing community within Scotland. And what they're trying to do is bring everybody together and then channel them through to the portfolio of projects. Then once you're within that environment, what they're doing is signposting you to the correct project that meets whatever your inquiry or needs are. So in this circumstance, the ones that are aligned to the AMBATS project will be brought through to us. What that then allows through this portfolio of projects is the transfer of knowledge and access to support for SMEs, and that covers across the full range of the AMCF projects. And what is also happening parallel to this is the existing supply chain and sector is providing specialist support and knowledge back through into the SMEs to grow what they're doing. And as we invest and grow what we're doing in terms of additive manufacturing and the complementary processes that go along with them, we will be feeding this knowledge back into the wider additive manufacturing sector to really boost and grow what we're doing in Scotland to be at that level of competition globally. And it's really worthwhile coming to speak to us about any and all ideas that you may have. So if you're not an SME and you're thinking, right, well, I can't access this project because I'm not an SME, don't worry, there are always different funding opportunities, and we have an entire bid team that are in place to kind of help everybody at all levels, from SME straight through to your large organizations. But what you find with additive manufacturing is that it's quite a democratized process. So what could be a situation is that you as a small SME are actually part of the supply chain for a larger company. So you could come together with us and the larger companies to form collaborative research and development projects, which is something that we do very often at both the AFRC and now the National Manufacturing Institute. So like I say, the main thing to take away from that kind of possibly overly complicated slide is really what are you, the SME, getting from the AMBATS project. So the webinar series will be providing you with lots of information, from really detailed analysis of all the different projects, but also the softwares and many other things that will be of benefit to you. And then it's really this access to equipment and support, all the support packages that we previously discussed, and that ability to develop prototypes that you perhaps may not have been able to do otherwise. So the key criteria to work on the AMBATS project is that you must be located within Scotland, you must be an SME, and finally, adherence to the horizontal themes. More information can be found about this on this website here, so Scottish Business Pledge, but some of the main points about it are essentially equal opportunities within your company and also the real living wage. So if you have any inquiries or you require more information, obviously the first point of call is always the NMIS website. So I've highlighted here how you can get in touch with us there. Or if you know that you've got something and you're ready just work with us straight away, please do contact either of the business development executives for the additive manufacturing and machining team, Alistair McDonough and Barry McGee. Thank you very much. Now we have some time scheduled for question and answer session. And I believe Mizell has been keeping tabs on all the questions and he will be running through them and passing them on to the room.
Hi, sorry guys. So apologies first of all if I mispronounce your name differently from what it is. We have a question from Thomas. He's asking, so whilst I think the systems are very interesting, why do we need these machines within NMIS if the HVMC already has an AEM center in England? I don't know if Stephen wants to jump in on that one.
Yeah, I can answer that. No, it's an interesting question, and it has, stemmed a lot of debate over the last, few years as centres have grown. Certainly for us in Scotland, there's a regional need, there's a regional capability need to support a local supply chain, particularly with SMEs who, they're not going to travel 200-400 miles to another centre. But what I would say is that you still don't want duplication. You're completely correct. So we envisaged that we would be working with different sectors, for instance. These, if you're talking about powder bed fusion again, maybe the materials are traditionally, they tend to be locked down to one material per machine. So again, we'd be looking at different materials to what already exists within the catapult. And what I want to say, and I think I've mentioned it 2 or 3 times within the slides, is that this is very much done in line with the rest of the HVMC. So we don't envisage that we're going to grow to a national centre in any of these technologies. We want to have a regional capability, but we want to use the strength of, for instance, like the national centre, who have a lot more people working on powder bed fusion than we do and will ever will. So we want to use the strength of the catapult network to support the businesses locally, and powder bed fusion, for instance, using that as a technology area. So I hope that kind of answers that question.
Thanks, Stephen. So the other question is from Peter Full. How will the NMIS look into the end life issues with some of the materials mentioned? I don't know if you want to jump in on that one as well.
Again, it's a very, very important topic, not just for additive manufacturing, but for manufacturing in general. Sustainability is becoming ever more prominent and required across all of our manufacturing processes. So it is an area that is forefront of our mind at NMIS. Actually, a lead on a remanufacturing strategic initiative within the centre as well, which looks about reinstating products back into service. But in terms of the end-of-life materials, we need to do a lot more in terms of additive. We need to understand what that full life cycle energy consumption is, and then you're right. What do we do with that product at the end? Just to flip that on its head when I'm talking about remanufacturing, I think using additive manufacturing, like I'd mentioned with some of the directed energy deposition processes there, like LMD, that's an enabler for reman. So that, that prevents things coming to the end of their life, if you like. If you can use the benefits of that technology, because it has a lower heat input, you can use that over, traditional methods. If you can use that technology to then put a part back into service, then you're stopping that going from into a landfill. But as an area, like you mentioned, it's an area that, not just as a centre, but as a nation, we need to do more around in terms of our manufacturing.
Thanks, Stephen. There is another one from Thomas. He's asking, do you have any capability to carry out optimization of design based on structural need rather than traditional machining techniques? I've seen a few pictures of very odd looking products, but haven't heard much about this type of optimization.
Yeah, so I can answer that one as well. So within the design for additive manufacturing work package, we're covering all the different optimization processes. Some of them we are more advanced with, so such as topology optimization, we have Altair software, but we understand that within the optimization processes, you've got topology, you've got density-based, level set method, and I'm going to be very cross with myself that I can't remember the fourth. But what is key to understanding with using additive manufacturing, you're not using a typical design for manufacture process. So your typical processes that you've been working with that are industry accepted, and things like your Pew and your Ashby methods, where you're looking at concept, the embodiment designs, detailed designs, etc. Some of that has to change for design for additive manufacture. And it's also worthwhile considering that the optimized form that is delivered from one of these softwares isn't necessarily the best solution as such, because these softwares are only ever as good as the information that you give them. So for instance, it will lack emotional considerations such as aesthetics and other engineering considerations such as manufacturability and how it might be held for particular post-processing processes such as, say, machining or heat treatment, or even metrology for actually measuring to make sure that the part that you have asked the machine to build you is what is delivered at the end. So I hope that covers that for just now.
Thanks, Grant. Well, I saw that Peter made a comment as well. I'll just read it quickly so everyone can hear it. So he's saying that this process is optimized using computer software, and it's optimized when using additive manufacturing to make these odd shapes. So some features are near net and require traditional machining to complete the process. So the whole point is to reduce manufacturing time and reduce material losses due to machining to a minimum. So saving costs, that's something that actually we've been discussing throughout the presentation as well. So that's a good point. There is another question, and that's from Fagner Coelho. Does the system use any feedback process to control production quality?
So if we take our LMD process, for instance, again, that's an area that we're putting more effort into and towards. Certainly there's, with any additive manufacturing processes, there's a lot of process variables that need to be controlled, and the way to do that is through process monitoring and control. So I think that's an area with the LMD system that over the next couple of years we certainly want to make more robust, so that we can get more data to inform how a process is performing. And certainly with Michelle, you can maybe touch on the WAM systems, but it does have the capability within the powder bed fusion Renishaw systems as well.
For one, we're developing the system, but definitely that's something that we're gonna go for in terms of how we can control the quality of the final component. And actually, we've been discussing in terms of some process qualification as well with different parties to make sure that not only the component, but also the entire process that we have within NMIS AFRC offers a high integrity final part. So, yeah. I don't see any more questions. So I don't know if anyone else wants to ask anything, or we can maybe just finish for the day.
Yeah, I think Laura may just have some final housekeeping and just to let people know about some of the upcoming NMIS Insights webinars. Is that correct, Laura?
Yes, thank you, Grant. We have another webinar next week, and it's specifically on questions around the National Manufacturing Institute Scotland and the Manufacturing Skills Academy. So please do join us next week. It's the same way to sign up through Eventbrite, 11:30 till 12:30 on Wednesday. And there will be a recording of this webinar available shortly on our YouTube channel. And we'd also finally be very grateful if you could fill in our survey, which will follow after the session too. Back to you, Grant.
Yeah, I mean, sorry, Grant.
Yeah, sorry, I've just seen a comment come through about alternative softwares, and I'll need to do a BBC here and say that we are completely technology agnostic when it comes to, we don't advocate one technology or one software over another, but obviously we do need to make certain decisions about which ones to purchase based on what we feel are the sector requirements. And that being said, if anybody would like to offer us any software technology, we're never going to say no to that. But it's best to speak to us, and we'll see what we can do. Because really what we're here to do is drive growth and innovation, not only within Scotland, but also as part of our role as being, or AFRC's role as being part of the Catapult network. We're really here to drive growth and innovation throughout the UK. Over to you, Stephen.
Yeah, Guy, no, thanks very much, everybody, for joining. I hope you've enjoyed the presentation, and there was some good discussion at the end there. So I think what I'll do now is I'll just finish up, and, you know, like Laura said, the presentation will be available on our YouTube channel if you want to look at it again. So thanks very much, everybody, for your time, and we'll log off now. Thanks.
Thank you.
Thank you very much, everyone.
Thank you, everybody, for your comments. I'm just going to close down the webinar now. Okay, is that all right, guys?
Yep.
Yep.
Yeah.
Right. Thank you, everyone.
Thanks, bye.
Hello.